Welcome to this introductory video on R and R Studio. It's a Nuffield Foundation e-learning resource in collaboration with the Institute of Coding and the University of Exeter. My name is Dr. Patrick English and I'm a lecturer in data science at the University of Exeter. And today I'm going to teach you a couple of things about the wonderful world of R. So chances are, if you're watching this video, you probably know at least a little something about what R is or what it's for. But even if you're kind of familiar with it before coming into this, hopefully this introductory video will teach you something new. I've been using R for the best part of a decade now, and I still pick up new things every day from all kinds of places. So firstly, R is fantastic. It's awesome, it's great. So well done for you for deciding to watch this video, to get yourself into R and to learn what R is all about. R is used by researchers, data scientists, statisticians, programmers, and all kinds of people all over the world. It's used in all disciplines and it's used in professional and academic settings. It has a huge community and it's just ever growing, and it's a really good sort of place to be at right now if you're looking to improve your statistical, your research and your analytical skills. So good job. Now, for those of you with a bit of computer science or maybe sort of computer science literature, knowledge or background, R is what's called a Turing-complete language, although sometimes people say it isn't, but they're wrong. They call it a statistical or just a programming language. But actually, R is quite a lot more general purpose than that. And its processes and its functions can be used on any other real world general purpose problems other than the one it happens to be working on or you have to working on right now. It has a lot of functions and processes that allow it to break into the undercarriage of your machine, get into its inner workings, interact with web servers, develop software, and so much more. So the power and the capabilities of R are massive. Often, R is referred to as a scripting language. So what does that mean? Well, there's two components to that. There's the scripting bit and the language bit. What does the term language mean? Well, language means that rather than pointing and clicking at a program to get it to do what we want, we kind of almost talk to it. We use what's called the command line or some scripts, which we'll come into in a bit, basically to interact with R, to get it to carry out processes, to store information, and to display things. We kind of communicate with it in a text format. In a way, it's kind of like having a conversation with a super smart statistical robot. You can write to it and ask it to do one thing, ask it to do another, tell it to do something else, and R will write back to you and talk back to you and give you the results that you want at the end and as it goes through. Now, the scripting component means that normally R works or is used by writing out many lines of code into what's called a script and then processing it all at once. So rather than asking it to do one stage at a time, we tend to write out lots of stages, lots of lines of code, and process them all at once and save them as individual R scripts. Now, R works with things called objects, which are kind of like little pieces of memory internal to the program, which we store things in to either call back, look at later, manipulate, or do further things with later down the line. And its key strength, I think, is how R can be used to manipulate data and functions in object form. And this kind of creates what we call an object-oriented program. So sometimes you'll hear people say R is Turing-complete, it's a scripting language, it's an object-oriented or object-based language. Basically, these all kind of mean similar things, and they just attest to the inner workings of R, its logic, and how we use it. Now, R can be used on its own through what's called the R console, which is kind of in the package that you download. It can be used through writing and executing text files, .txt files with calls to R at the top, or it can be used with something called R Studio. Now, most commonly, people will use R Studio to interface with R. It's kind of like a general user interface. And this is true of beginners, it's true of industry professionals. Most people will use R Studio to carry out their R programs, their R scripts. So before we get into some examples of how to use R, firstly, for those of you that haven't yet, we're just going to cover how you download R and use R in R Studio. So firstly, you need to download R from CRAN, which is the central network where all R things are stored. So if you head over to that link there and select your appropriate download, whether you're on Linux or Windows or Mac, and then you need to install R onto your machine. So that's the first few steps. Then you need to go and download R Studio. So R Studio is a separate program. It does not come with R, and crucially, R does not come with R Studio. So you need to install R Studio after you've downloaded it, after you've installed R on your machine. It's very important that you do those steps in exactly that order as if you try to install RStudio without first installing R, things just won't work. If you only install R, you'll get lost for the rest of this video because things won't look the same and things won't behave the same. So make sure you've downloaded R, installed R, downloaded RStudio, and installed RStudio. All right, so let's begin now to look at some of the practical things we can do with R and look through some worksheets. So here we have our RStudio interface. So when you first open up RStudio, it should look a little bit something like this. You may have some text over here in this little bit, you might not. In this pane down here, basically this is the sort of the folder structure of your computer. That might not be there, it might have defaulted to the help pane or something. And then up here, this pane up there should be empty. So essentially, what this is kind of called the environment that you're working in RStudio. And RStudio provides an environment in which to work with R. And these different panes all have names. So this pane here is what we traditionally call the console pane, the return pane. On the top right here is the environment, the global environment. This is where our objects will be stored. And then down in the bottom right here, we have a kind of multi-purpose pane where the files are sort of listed. We have plots here, details on packages, and sort of our help and viewer panes. We'll kind of go through each of these as we use them in the lesson, so don't worry about it too much for now. The important thing to start off with is to come up here into the top left-hand side of your screen and open up what's called an R script, which is this very first thing here, or the shortcut there, Control Shift and N, or Command Shift N on the Macs. What you'll then see is an R script will open up in front of you, and you'll see a flashing cursor up in line 1. Now, as I said before, R is a scripting language, so traditionally we will write scripts up here and then ask R to process them. And R will run and return everything in its console, in this kind of internal processor, which is what's represented down here. So, to do some sort of light touch examples of how that's worked, we're going to do an example which is common to any programming language, any language that you start learning, which is called Hello World. And what we're going to do is we're just going to ask R to print back to us the words Hello World. Now, first of all, we're going to do it up here in the script that we just opened. And we're going to do what's called a function, and the function is called print. And you'll see here when we start typing functions that we get helpful suggestions from R as to what we might mean. We just want print. And then in quotation marks, because we're going to deal with characters, and anytime we deal with characters, we must put quotation marks in. We're going to write the words Hello World. Now, enter these lines, nothing will happen, nothing runs. Unlike some other languages or some other software, R doesn't run anything unless you explicitly tell it to. So it's just kind of sat there now at the top of the script. To run this, I can do it in a couple of ways. Firstly, I can highlight this bit of code here, and then for me on the Mac it's Command and Enter, on Windows it'll be Control and Enter, and I can just press Command and Enter. And what you'll notice is that after pressing that, R has run it down in the console here. So print Hello World has appeared here, and R has returned something to us. Quite simply, it has printed Hello World. I don't have to highlight the line in order to do it. I can do Command and Enter with my cursor just sort of flashing on the line. It can be at the front of the line, it can be at the back of the line, it can be in the middle of the line, does not matter. I can also use these buttons here. So this little button here, Run, will do the same thing for me. So that is running something very simple, and R is returning it back to us here in the form of Hello World. It doesn't have to be Hello World. I could do print and say Hello Students, and then I can put my cursor on that line and run it, and Hello Students will return. If I then run the script here, nothing happens because my cursor is down here on line 4. However, I could quickly select all of the script, press run, and it will run everything for me down there. So multiple ways to achieve the same thing. Okay, now we're going to think about how we're going to use objects in R and how R works with objects. Suppose that we want to know the answer to the sum 3 plus 5. You'll notice here that I've started typing into the console. So I can run things if I want to directly in the console and R will return it back to me, or I can run it in the script and run that line either by highlighting or just putting my cursor on the end and doing Command and Enter, and I get the same thing, right? It doesn't really matter where I do it, R will give me the same answer and complete the same process. Now, suppose instead of just asking R straight up, what is 3 plus 5, we could do something like make an object called y, and we're going to assign y, and this is how we assign things in R. So we use the less than sign and the little dash together to assign something. So we're going to say that y is 3. I'm going to run this line. Now, instead of something appearing down in the console down there, something else is going to happen. Now, my command to assign y is 3 has appeared, but it hasn't returned anything because I haven't asked R to return anything. Unlike when I asked it to print something or do a sum, I haven't asked it to return something. I've instead asked it to store y as an object. And R has told me that it's successfully done that over here in the global environment. So it's telling me that in its internal memory, something called y takes the value of 3. And this is now stored for as long as I want it to stay in R's internal memory. And I can call it back either in the console or in the script just by typing y and running that line. So now I've asked R to tell me what y is, and R has said that y is 3. And just to demonstrate the point, I can put y into the console and the same thing happens. It chucks it back at me and says y is 3. Now I'm going to make an object called x, and x is going to take the value of 5. I've run that line, just again to reiterate the point, I can just run like this, whatever, it doesn't matter. I don't get any returns. Instead, x has now appeared up there, and x has the value of 5. So we already know what 3 plus 5 is, it's 8. On line 13 down here in my R script, I'm going to add together y and x. Now, if you think about the logic of adding together letters, it doesn't really work, right? What is y plus x? That doesn't really make sense. But R does not recognize y and x as letters or as characters. R recognizes them as objects, which it has stored in its internal memory. Remember when we did want it to work with characters or letters or what have you, we put quotation marks up here. So these are not in quotation marks. So R is not going to think that you're trying to add y and x together. It's going to look for objects called y and x and add them together. So if I run this line, the return is 8. Good. Everything's working as it should do, right? We have 3 and 5. We've added them together and that's 8. Now, R will only look for objects and find objects where they exist. So for example, let's say in our heads, we've made an object called z, and z is 10, and we want to find out what 3 plus 10 is, and we expect 13. If we run this line, we get what's called an error message. Now, R has a fully integrated error message system, which is really good. Sometimes can be a bit confusing, and the red text can be a little scary, but actually, if you sort of spend a little bit of time working out what it's telling you, it's quite intuitive. So, it's telling us that the object z is not found. Well, of course, because I just invented z in my head, I didn't commit it to memory, there's no object called z that R knows about. So I say, silly me, whoops, I need to make the object z. Here, z is going to take the value of 10. And now, when I run y plus z, then we get the answer down there, which is 13. It's also crucial that we call objects exactly as we store them. So I've now made my object called z. But let's imagine that I wanted to call back z, I wanted to inspect z, and I put a capital Z there instead and try to run this. So I run it this way this time, why not? It says object z not found. And we might think, what? That doesn't make sense. I know z is there, I just committed z and I just used z. But R is quite fussy. R wants us to refer to objects and indeed functions exactly as they are specified in its memory. So we can't use a capital Z to refer to an object called Z, which is a lowercase z. We have to call it exactly as we committed it, with the lowercase z. Okay, so that is how we work with objects, a basic kind of introduction to how we assign objects, how we can manipulate objects. Let's say we wanted to change an object that we already have. So we've got our Z there, and we want to create a new object called P. I'm going to take P to be the value of Z minus Y. So again, thinking in terms of letters, not obvious what's going to happen here. But if we think about it in terms of objects, I will recognize that we're trying to create a new object called P, which is going to have the value of Z minus Y. So if we run this line, an object called P has not appeared in the console, but it has appeared in the global environment, and it has the value of 7, because Z is 10, minus Y is 3, is 7. So that's how we can assign new objects, create new objects using existing objects. And this flexibility of R to be able to call, use, manipulate, generate objects just like that, using other objects as well, is one of its main strengths. Okay, so we're going to start now looking at some things called functions. We've already looked at the print function, where we've asked R to print something that we've told it what it is. Interestingly, by the way, we could say print Z, and we can print objects too. We don't have to just put in letters or words or what have you. We can put objects into the print statement, and it will give us objects, the value of the object back, right? It said the Z is 10. This is exactly the same as just running the line Z. Same thing. Okay, so what we're going to do now is look at some other functions and look at some other types of data. So let's assume that we want to create a sequence of numbers. And we're going to create a sequence of numbers that have the length of 20. We're going to use a function called seq to do this, seq. And we're going to say we want it to start at 1 and finish at 20. Down here, we will get the output. So we have a sequence of numbers from 1 all the way through to the number 20. Let's go back into line 27 and let's assign that as an object called nums. So nums is going to be this sequence. And nums appears here in the global environment alongside everything else that we've already committed. You'll notice here that rather than just having a number or the list of numbers, R is giving us a bit of extra information here. It's saying that there's an int of a range. What does this int mean? Well, this refers to the different ways or different types of data which R can store and handle, and different ways in which it classifies data. We can check this by running the class function. And the class function basically is a way for us to ask what type of data does R think we have, or has R classified our data as. So we've made a long string of numbers there. So let's say, okay, what is the class of nums? The class of the object we just made. R is saying that this is an integer, although these are integers. And we can check how that compares to our other numbers we made earlier. Say, what's the class of Z? That is numeric. So integer and numeric are two different ways in which R can store and handle numbers. I won't go into the difference in this class, but if you want to look that up, please do. But there are essentially two different ways in which R can store numeric data. It can store data which are numbers. There are other different types of data which R can store and work with, which we will go into a bit later on. All right, so we have our long list of numbers there. What about if we wanted to generate a random sequence of numbers rather than just a list of numbers which ranges from 1 to 20? Well, to do that, we can use another function which is called runIf, or Unif, or I don't know, runIf. Now, when we did our sequence function here, we defined what's called arguments. And you'll see here, hovering above our Unif function, well, it's just gone now, there was a little bit of help telling us what arguments this function takes. Essentially, an argument just means information. So when we run functions, we need to give our information as to what we want to put into the function. So for our Unif, we can call that back by using this little function here, this little question mark, and we say, all right, can we have that again, please? And we'll open up in this pane here what's called the help file. And it tells us that for our Unif, we need to give it the n, the minimum, and the maximum, where n is the number of observations, so the sort of the length, if you like, and the minimum, what is the minimum value, and the maximum value of this randomness of numbers it's going to generate. Okay, so we're going to fill out this Unif function with some arguments, and we're going to say that our n, defined down there, equals 20, so we want 20 numbers. We're going to say we want the minimum number that could possibly be in this random generation to be 25, and we want the maximum number to be 60. So we've got our function there, we've taken our 3 arguments, and we've defined them with some values. And if we run that, then we get this output here, where R has generated us 20 completely random numbers with integer and fractional parts, and that's good. So that's kind of the output that we wanted. Now, we're going to put this into an object. We're going to do seconds. We call it object seconds, and we're going to define that as this command here. Now, because this is a random sequence that's being generated, seconds is not going to equal this batch of random numbers down here. So if we run this, we're going to see already that seconds starts with 27.5, 38.1, and these numbers are different. That's because they're random. And when you're running this at home, when you're looking at this script and trying to follow it, or you're doing it afterwards, you'll get a completely different set of numbers as well, because it's random. It's randomly drawn from what's called a uniform distribution. Don't worry about that too much. It just means that you're just going to get random numbers that can be anywhere in between your minimum and maximum values. Now at this point, it's probably worth talking about vectors. Now R is a vectorized language, another term to throw at you there. Again, not a term to worry about too much, but essentially it means that it kind of treats data as, for lack of a better term, lists, right? We have some numbers or some characters or some factors perhaps, and they're all kind of arranged in long vectors, really long lists, long sort of combinations. And R will kind of look for vectors and sort of behave accordingly depending on what class those vectors are, etc., etc. I guess the take home from that is that R sort of thinks about data as being in lines. And we can ask R if our seconds object is a vector by saying is vector seconds. And it says that it's true. So an object can kind of be two different things at the same time, or seemingly different things at the same time, right? So we've just asked, is it a vector there? But if we ran the class command on that there and says, okay, what's the class of seconds? It would say the class is numeric. Because we're kind of asking two slightly different questions there. So class doesn't say, the class is vector, because that's not really the class of the data, that's the class of the object. So when we say, is it a vector, we're kind of asking a question about the object. When we're talking about class, we're kind of asking about what are the data inside those objects, inside that vector. So that's why it says sort of class is numeric rather than class is vector. All right, so now we have our random sequence there. We are going to make something else. But before we do that, we're just going to actually do a very quick plot of this. We're going to plot a histogram. If you don't know what one of those is, not to worry, have a quick look up or just look over here. This is the histogram of the object of seconds. So it's taken our data, seconds, and it has made a histogram out of it, where we have the x-axis here, we have categories of the data, and then the frequency is on that y-axis there. So we can see we've got quite a lot of clustering between 25 and 40, and then some less sort of common values over there on that extreme end, which is interesting for a random distribution, but there we go, probably because we only have 20 data points. So that's just a quick demonstration of how quickly R can make nice, lovely plots for you. You can do all kinds of different plots. Feel free to go look that up in your own time. But it's very, very quick, very powerful, and they're quite nice looking. They're all right. They're not too bad, those default plots. And if you look into it a little bit further, you'll find that you can define all kinds of arguments. Like you can change the title, you can change the x-axis, you can change the colors with some very, very, very simple arguments. So it's worth knowing and worth looking into. Okay, we're going to make another variable now, another vector. And this time we're going to create what's called a factor. I mentioned that before, and we're going to go into a little bit what that is now. So we're going to use this function called C, which is a concatenation function. And we're going to put together two shorter things into one longer thing. So two shorter vectors into a longer vector. We're concatenating. And inside this C, we're going to make a vector, or a sort of a list of numbers, which is 20 observations long, and it's going to have 10 ones and 10 twos. And then we're going to turn that into, we're going to treat that as a factor variable. So this is how we concatenate two things. Well, there are two ways really. We could define the two objects separately and then concatenate them together, or we can concatenate things inside the function itself. We don't have to make the objects first and then bind them together. So we're going to do it the latter way here. So we're going to organize this as a sequence. This will look familiar, except we're going to do a little bit more. We're going to flesh out the function now and actually define the arguments and say we're going to go from 1 to 1, whereas here we're going from 1 to 20. So we're going to go from 1 to 1. And we're going to say an additional argument, a length of 10. So that's going to create 10 ones for us. We're then going to pop this comma here. Now this delineates the objects or the data which the concatenate function is going to bring together. So that's kind of one complete argument. And if we sort of run that on its own, we get down there our 10 ones. Then we put a comma, and then I pressed enter there to move down to the next line. You don't have to do that. That's just what I like to do. We're going to make another sequence that's going to be from 2 to 2, 2, 2, 2. And the length of that is going to be 10 again. Again, if we just run that in isolation, oh, I forgot to include the other bracket there, then we get our 10 twos. And if we wrap those two together, so we run all of this bit of code with the concatenate function, you can see that the C function has just bound those two things together, pop twos on the ends of the ones, and made a list of 20 long. And then we're going to define that as an object, and we're going to call it, what should we say, day. So we have day 1 and day 2. And then that pops up there as another vector. All right. Next thing we're going to do, we're going to introduce another function, and we're going to actually start building some data. We're going to build a data object. So we have sort of individual bits of data there where we have vectors that have different things in them. We're now going to build what you might sort of more commonly recognize as a database or a data file. We're going to put all these things together into one object. And to do that, we're going to use the cbind function. So we have the C function here, which concatenate things. And cbind, kind of like think of it as column binding. So we bind together columns, we bind together vectors and kind of put them next to each other in the same structure. And this is going to create what's called a matrix. Now, a matrix is a fairly common, although not hugely common, class or sort of type of object in R, whereby all the data in that have to be of the same class. So we're thinking before about numeric data, character data, and there's another thing called factor data, which again we'll come to in a bit. A matrix has to bind together all of the same class of objects. It can't handle more than one different type of object. And we'll get a little bit more into why that's important in a bit later. We're now going to bind together the objects that we've made before with our values in. So we're going to say we're going to put together nums, seconds, and day. We don't have to define what these are. We can just call straight to the objects. We don't have to sort of make any of these arguments again. They're already stored. So we're going to pop these together, and the output looks a bit like this. So we can see that R has popped our functions, our data next to each other. This listed them, and this kind of created this variable structure with observations, this kind of columns and rows thing here. So we're actually going to make that now into an object. So we're going to say data is that. And we can see that it appears up here in the global environment as data. And we have data that gives us some information about the dimensions there. And we can sort of use the function called dim on data and ask it to tell us how many observations there are, how many rows, and then how many columns there are, 20 and 3. We can also ask, okay, what class is data? It says it's a matrix or an array. So where we are, we've made our matrix there. And as well, we can ask more explicitly, okay, is this a matrix? And I'll say, yes, true. Very good. Okay. So now I'm going to introduce a package. Now, packages are sort of additional things that you can build onto R. There's thousands and thousands and thousands of them listed on the central network, and even more listed on GitHub if you're familiar with that. And essentially what they do is they kind of provide some more specialist functions, some more specialist processes that you can run, which sort of the base R language, which is what we're using currently here, might not cover. So for example, there are some really good data visualization packages, which can take what R can do here in terms of histogram and make it even better. There are some packages to do things like multi-level modeling, there's things to do like Bayesian statistics, etc., etc. Don't worry too much about them for now if you don't really want to think about it. But I'm just going to demonstrate here how you might install and use a package, and you can come back to this perhaps at a later date. So what I want is a list of random names. And to do that, instead of thinking about 20 random names to bind into my data object there, I'm going to install a package. Use the install packages command. In quotation marks, I'm going to write random names. I've already installed it, so it's giving me a little warning and saying, well, you've already got this, and I'll just, for the purposes of this, say, yeah, whatever, that's fine, I don't mind. But essentially what it's going to do is I will look into the sort of central repository of packages for this package called random names. It finds it there, downloads all the binaries, and it basically installs that package onto our system and into our session. I then call that package that I've just loaded using library random names, and then that will load up the package. I get this little warning message there, don't worry about that, and that will load up the package into our session. Interestingly, if you are interested in all the packages, they are listed here under the packages tab, so I've got quite a few. You probably won't have too many of these if you've literally just downloaded and opened R. But if we have a quick look to see where the random names package is, if I can remember my alphabet, that would help. Here we go. So we can see that random names has been popped into our session and it's been loaded there. We can also sort of use this menu here to load packages. So let's say we're going to load reshape2, and that will automatically sort of do the library command for us. So we've loaded a package called random names, and this package, as the name suggests, is for just generating some random names, which is kind of handy, right? So I want to get a list of 20 random names. So I'm going to use the function random names. I'll start typing it, handily it comes out there. And we can actually be more specific about our names. We've got some helpful information here which says, you can say, as well as how many names you want, you could define gender, ethnicity, and you can say, I just want first name and last name, etc., etc., etc. I'm not too bothered about that. I just want to have 20 random names. And here we are, we can see that R has just generated us 20 completely random names, which is great. Again, I want to make that into an object. So I'm going to say people is the output of 20 random names. And there we are, we can see up there that we have 20 random names have been generated for us. Just going to put that back to the plots panel. Okay, so what I'm going to demonstrate now is the difference between a matrix and what's called a data frame, because I'm going to try and bind in the names into the matrix of numbers that we already have. Now, recall back to what I said before in terms of the fact that matrices can only, or matrices can only handle one type of data. So, if I try to bind together cbind data, so the data object we already have, with people, the output looks a little bit like this. Now what's happened, the eagle-eyed among you will notice that we have quotation marks around our numbers. Why? Well, because R has seen that people is character data, looked across at the data confined within data and said, well, that's not character data. Matrices can only handle one type of data, so I'm going to force all of the numeric data into character data. So in a way, we've kind of preserved the data, although it's now in completely the wrong format. This is now a character. Instead, in order to actually preserve the format of the data as well as the data themselves, we are going to make use of what's called a data frame. Now, a data frame is much more commonly used sort of storage facility of data in R, because data frames can handle any and all types of data simultaneously. It doesn't have the rule with matrices where you can only have one type of data. It will happily have numeric, integer, character, whatever, all these different types of data together within the same object. No problem. So the first thing we're going to do is we're going to reassign data. We're going to overwrite it, whereas before we were sort of assigning new things to new objects. We're going to actually say, okay, overwrite data, and we're going to say as data frame. So we use the function as data frame, which basically takes whatever you put in there, i.e. data, and turns it into a data frame. So we're saying as data frame, data is data. So we lose the original data up here, and instead we've now got data is kind of transformed. It's got this little box over here because this is now a data frame. And we can say, okay, what is the class of data? It is a data frame. And we can view this data by sort of clicking this box over here, and it will pop up here where our R script was. And we can see that everything's coming together nicely, no problem at all. Now, we're going to introduce at this stage the $sign operator. This. Now, the $sign operator is a way that R will look inside objects for other things, maybe a vector, a list, or something else. So in our case, we can use it to look inside data at the variables that we've constructed within. So let's say we're going to say, all right, what is the class of data $seconds? And tells us that data is numeric. What is the class of data $day? Numeric. Now actually we want to change data $day. We want to change day into a factor variable. We don't want that to be numeric. We don't want it to represent numbers. We're going to say it means day 1 or day 2. And that's an example of a factor. So again, we're going to overwrite. We're going to say, all right, data $day. So we're going to define something called data $day. So inside the object data, there is a vector called day, and that's going to be as factor. So in the same way that we went as .dataframe, we're going to say, okay, take this thing and make it into a factor. I'm going to say data $day. Now, if we do the class of data $day, it will say that this is a factor. Notice that when we look at the object, it looks the same still. R has just sort of transformed its internal thinking about what that vector is, what that variable is, as a factor rather than representing numeric data. And you can do a little bit of reading up on sort of what is the difference between sort of numeric factors and numeric data, if you like. I'm not going to go into that here, but that's sort of just an example of how we change things from one type of data into another. All right, so now that we have that sorted, we can effectively put our name data inside the rest of our data. So again, using the data $sign operator, we're going to say data $people is defined as people. So our object of there, people, is going to go inside data and it's going to be called data $people. So we can run that line of code, And then when we open up data, we can see, aha, people has gone inside there. Nice and easy, no problem at all. And crucially, the class of the rest of the data has not changed. So if we check for data $seconds, it's still numeric. If we do data $people, that's now character data. So you can see that the data frame can handle the different types of data, whereas the matrix cannot. We're going to do something a little bit different now as well. We're going to create a new variable by cutting up another variable, and we're also going to change the names of the data frame that we have in front of us. So we have nums, seconds, day, and people. Well, let's say, okay, we're going to change the names, those column names, to be a little bit more informative, and we're going to use the names function here to do that. So we're going to say that the names of data are going to be defined as, I'm going to use this C function here because we're going to define a list of something. We're going to define a vector. We're going to define something that which kind of needs to understand is kind of a standalone list, not just some sort of random splurge of characters. So we're going to say that the first one is going to be trial. The second is going to be seconds, which is going to capitalize it. And that one's going to be day. We're going to just capitalize that as well. And then the fourth column, it's important that you do them in the order that they appear. The fourth column, people, we're going to say participant is in there. You can see when we click on data, the names will have changed. So what we've sort of made here together is a database where, let's say we have 20 participants and they've been asked to complete a task. Half of them did it on day 1, half of them did it on day 2. This is the number of seconds that they took, and this is kind of like the trial ID, the sort of the numeric identifier of the trial. So each sort of individual trial gets its own number as well as its own person. So that's what we've kind of created there, an imaginary experiment, and we've recorded all of the data from that. So let's say we are interested in a certain distribution or a certain kind of collection of these number of seconds. We're kind of like, yeah, well, you know, this is interesting in and of itself, but we want to see, sort of categorize this and see how many people did it in, say, between 25 to 35, 35 to 45, and 45 plus. I'm going to make a nice table that will tell us that information. So we can use a function called cut to do this for us. So we're going to make a new vector inside data. So we're going to do the data $ again, and we're going to say speed category is going to be defined as the output of this function, cut, and we're going to cut data $seconds. Now our next argument we need to define is breaks. So it says there, yep, breaks, it recognizes what that is. And we're going to break up seconds using the sort of histogram down here that we can see. We're going to say, all right, let's start at 25 and go from 25 to 35. Then let's go from 35 to 45, and then up to the maximum value, which is 60. Remember, we defined our minimum and maximum there. So when you break up a numeric vector, the first and last should always be the minimum and maximum. And then you can kind of chop things up in between. We don't have to do this, but we're also going to create some labels, some nice informative labels for our new categorical, our new factor variable. And again, C, because we're sort of making a list of things, a list of conditions, we're going to say the first category, which is going to be between 25 and 35, is going to be under 35 seconds. Ooh, separating these by commas. And then we're going to say between 35 and 45 seconds, there's that gap in there, and then finally 45 seconds and above. So we've defined a new variable, we're going to break up seconds, and it's going to go into these numeric categories with these labels. So we run that, look inside our data object, and here everyone now has a category according to which I guess what's the best word for it? Which group they're trial time comes in at. And then we can use a function called table to say, okay, how many people are in each, or how many trials are in each category. So we say table, and we do data $speed category, and it says that 11 people were under 35, there were 7 people between 35 and 45, and 2 people were 45 seconds and above. Now, the final thing that we're going to look at in this opening sort of explanatory video is something called subsetting. Now, subsetting is quite a useful thing to do when we want to investigate or pull out or sort of make inferences, graphical representations, or maybe even entirely new data sets out of particular people or particular conditions within a wider data set. So let's say for whatever reason, we're only interested in people that took this test or did this experiment on day 2. And we don't care about anybody in day 1, and we need to make a new object where we just look at day 2 people. So we're going to make a new object called day 2 experiments, and that's going to be defined as a subset of data, so we're subsetting the original data. And now we need to give it a logical condition. R is a logical language. It uses Boolean logic. Again, go have a read up on that if you want to. But essentially what that means is things are kind of either true or false, and we need to specify some kind of condition, some kind of argument, and R will evaluate whether things are true or false based on that and give us our output accordingly. So in this subset argument, we're going to say we're going to subset data where just refresh my memory, the day, that's it with a capital D, where the day is equal to, there are 2 equal signs here. This is really important. It won't work if you just put 1, because we're kind of saying it's exactly equal to this, rather than some kind of assignment argument. We're saying this is exactly equal to 2. And what that is going to do is it's going to pull out and put into that new object every observation, every row, where the condition of day equals 2 is satisfied. So it should just pull out all of these. So if we run that, we get this new data here. It's still a data frame, and it's got 10 observations. So it looks like that's worked quite nicely. We can double check that. And yes, everyone who is on day 2 has now gone into this object. There are no day 1 people here. Just very quickly, we can sort of replicate this another way. We don't have to say equals 2. We can use the negation of that, and negations are done in sort of logic using the exclamation point. We can say, all right, when day does not equal 1. So this might be useful, for example, if we had lots of different days and we just wanted to exclude people from one particular day and take all the rest. Rather than writing out loads of long arguments, we can just say, okay, not equal to 1. And that will give us exactly the same. So I've just ran that line there, and data experiments still equals that. We can also use these arguments to create even more sort of specific conditions. So we can say, all right, day 2 experiments fast is going to be subset the data where day equals 2, and, so this is kind of a Boolean and, which basically means it's going to look for all the things that satisfy this and also satisfy the next thing. And we're going to say that speed category is under 35 seconds. So speed category is less than, oh no, that's not going to be right because we've defined that as a factor, haven't we? So it's equal to under 35 seconds. Run that, and it's telling us that there are 6 people for which that is true. I started doing this, so I might as well carry on with that. We could have also done it like this, so we can say, rather than look at the speed category, we could say that speed, or seconds, that's called, isn't it? So seconds is less than 35. And now it gives exactly the same result. We've made the same argument, just in a different way. So you can have a look as well at the OR condition as a different way of doing this. So we could say Rather than an and, we're going to put a Boolean or in here, which is sort of the long dash. We're going to name that object day 2 experiments or fast. So this time we can say take everyone who's in day 2 or whose number of seconds is less than 35. So that means we're going to include some day 1 people who are under 35. So if we run this, we can see day 2 experiments or fast is 15 observations, where everybody who's in day 2 is in there, and anyone from day 1 who's under 35 seconds, right? Because the condition or seconds is under 35 applies to everyone regardless of the day. We'll just finally look at R scripts, how you can save them and reload them. So the R console will not remember things after you quit R and start it again, and it actually sort of clears out its internal console memory every so often, so we don't get things stored in here. So the reason why I've been writing in the R script is that this is all permanently stored there, and we can save it and reload it, so we never have to sort of worry, oh, how did I cut that variable up, or how do I reproduce all of this, because it's all saved in the R script, which we can then reload at any time we like, and we can take bits of this code and put it in different R scripts and what have you. So it's a really useful way that R can help us out. So up here, I'm just going to ask R to save this script, and I'm just going to pop it on the desktop, and I'm going to say lesson script, save it there, and then I can close this. And rather than panicking and being like, oh no, oh god, everything's gone, how did I do that? I can ask R to open up things again, go to the desktop, look for lesson script, open it, and there we are. It's all there, it's saved everything for us, and that will stay on our computer as long as that file exists. So I hope you found everything that we've gone through today useful. This is very much a sort of beginner's entry-level R video. There's loads more resources you can find online. Stack Overflow, Stack Exchange are brilliant. There's lots more YouTube videos. Look out for more things by the Nuffield Foundation, the Institute of Coding. And yeah, good luck on the rest of your R journey. And I'm sure I will speak to you again soon.